to be a review. Hopefully you are able to learn something in this presentation. With these webinars, I'm aiming for 30 minutes. Some may be a bit longer, some may be a bit shorter. We'll see how things go and adjust accordingly. Like Pat mentioned, everybody is muted, so to keep the background noise to a minimal. If anyone has any questions, we will have a question period at the end of the meeting before we close things up. Today we are going to review the CPU assembly hardware. The CPU assembly comes with all the boards mounted within. It has 4 hand-tightened bolts that mount the motherboard cover plate. This plate rarely needs to be removed as there is access from the bottom to most of what you need to set up the panel and for basic troubleshooting. In addition to the bottom access, there's also 2 holes in the front panel that allow you to see status LEDs for the CPU heartbeat on the left. This is normal operation of the heartbeat of the CPU. And now on the right, we'll take a look at the CPU COM status light. Here's the normal healthy operation status of COM port 1. And here, if connected to a overview communication, would be the COM port 2 status indicator. We have a few different standard models of the MYPRO Touch Plus. The standard configurations are the 011, which is our base model panel. The 111 is our condenser model. The 211 is the chiller model. The 311 is our condenser with chiller model. And the 321 is the full spec model. We'll break down exactly what these numbers mean towards the end. The differences are what the panel is capable of due to hardware. The motherboard or main board is just that, the main component of our CPU assembly and what everything is connected to. We have our board connections, which we will talk more about in a minute. The power to the board is a 24-volt DC supply. There's a nickel-style 3.5-volt battery for memory backup. This requires changing every 2 to 3 years, depending on the panel usage. When technicians are changing this battery, it is best for them to leave power on to the panel. Pat, can you just make sure anybody new coming in is muted? Just got background on my side that's throwing me off a bit. Here is the CPU update port. Communication to human machine interface, or HMI. COM port 2 for Modbus RTU communication to a supervisory system. And the CPU reset button. This button is really only needed if you are instructed to do so during troubleshooting while you're talking to one of the control specialists. And here we have the part numbers for Canada and the US. So the motherboard is our starting point, but let's build off of this. To access the rest of the boards, we need to come back to the CPU assembly. The assembly is made up of 2 layers, the motherboard on the top layer or the front layer, and the access to the lower layer or back layer. We have a hinge on the left side of the middle plate. On the right side, there are two peg style fasteners. When you click or pull the pegs out, you will unlock the door. To lock the door, you just push the pegs back in. So if we unlock the door and swing it open, once we've hinged the front section open, we see the I/O boards mounted underneath. Some of these boards are stacked, and I will show you a standard construction of these boards once we know what these boards actually are. So for now, let's blow this apart. Spread them out here so that we can have a better look at them. Here are all the boards of the CPU assembly. Let's start with the analog input board. Here is an animation of the ribbon cable connection point to the motherboard. And here we have the ribbon cable connection points on the analog input cards. These cards are 8-channel cards each. A minimum of 2 boards are required for a panel to operate, for a total of 16 analog inputs. One note that these boards do require a connection to the 24-volt power supply in the panel. Because we have 2 boards per panel, and they don't just look identical, they are completely interchangeable, we need to have a way to identify which is which. To identify board 1, we have 2 rotary switches that need to be set. Each of these switches need to indicate 1 for these boards to operate correctly. When you receive a panel for startup, or on a package, a new panel, these switches will be set correctly. If technicians need to change one of these boards out due to a malfunction board or a defective board, they do need to take note of these and make sure that these are set correctly. If we rotate the board to take top view of the board, we can see the Phoenix connectors, wire connectors, and here we have the channel assignments and the channel numbering. Here's the wiring for board 1 with 4 to 20 milliamp current sensors wired to the hard-coded channels. These channels will always be the sensors indicated here. To be able to switch these sensors to voltage sensors, you need to toggle the corresponding dip switch. Channel 1, switch 1, channel 2, switch 2, and so on. When dip switches 1 to 8 are switched up or off, the inputs accept a voltage sensor. When switched down or on, the inputs accept current 4 to 20 milliamp sensors. One other note on board 1, switches 9 and 10 need to be switched to A. That's it for board 1. And here's part numbers for Canada and the US. Everyone will get a copy of this once the webinar is completed. We'll send this out in PDF form, so you don't need to really worry about taking notes of these part numbers. So along with input board 2, we already know, so analog input board 2, we already went over the connections. And yes, the way our panel is configured, the motherboard connects to board 2, and board 2 jumps to board 1. To identify board 2, we again need to utilize the rotary switches. Both switches need to point to 2. If we rotate to look at the top view, we can see the Phoenix connectors or wire connectors again, and the order of the channels and the channel assignments. The difference to analog input board 2 is channels 15 and 16 are 2 connection points We have an A channel and a B channel. This is for our slide valve and our VI position. And I'll explain a bit more in just a second. Here we have the wiring for a few 4 to 20 milliamp sensors on channels 9, 10, 11, and 12. However, on channels 15 and 16, we are wired to 15B and 16B. 15B and 16B are our connections for our standard potentiometer that we use for the slide valve and the VI indicator. However, if we require to use a different indicator, you are able to use a current or voltage sensor by toggling switches 9 and 10 on this card to A. 15A and 15A and 16A will then select a current or voltage sensor. You again use the matching dip switch on this card. So channels, as this card is the same as card 1, the switch 1 is channel 9, switch 2, channel 10, and so on. Channel 15A would be switch 7. Switch 8 is channel 16A. So 15 and 16 have 2 dip switches. Switches 9 and 10, switching between the A and B channels. And then switch 7 and 8, switching between current and voltage sensors. That's all for analog input board 2. And again, here we have the part numbers for these boards. Here are analog input boards 3 and 4 and the channel assignments for these boards. The connections are the same as analog boards 1 and 2, and again with the rotary dip switches. This concludes the analog input boards. Next, we are going to talk about the analog output board. And here's an animation of the ribbon cable connection to the motherboard. The analog output board has 4 channels that are 4 to 20 milliamp outputs only. Here we have all the possible channel assignments and the order of the channels on the top of the board. One note that this board does require the connection to the power supply in the panel, the 24-volt DC supply. Here's the wiring diagram of the output. These could be devices to be controlled, such as a motorized valve or a VFD speed control. Or this could also be wired to a monitoring system to monitor slide valve position or pressure, temperature. The list is 25 items. You're able to use any 4 of these analog outputs. If you require more than 4, chances are you'd have a communication system to an overview system. And here we have the part numbers again. That wraps up the analog output boards. Next, we're going to move on to the main digital I/O board. And here we have the animation of the ribbon cable connection to the motherboard. The main digital I/O board has 10 digital outputs and 6 digital inputs. The outputs are 120 volt AC dry contacts, while the inputs are 12 volt DC self-powered channels. This means no external power supply is needed or required. If power is connected to these inputs, this would damage this board. Here we have the channel assignments and the order of the channels with outputs in red and the inputs in blue. Here we have a wiring diagram found in the back of our manual for the main digital I/O board. This drawing is different than what the drawings you would find in our panel, as the drawings in our panel show all of our wiring for the terminal blocks within the enclosure. This drawing is just for the CPU assembly. Here we have an animation showing you the wiring of the main digital I/O board. Starting with the 120 volt power feed, that is E-stop protected. Next we have channel 1 being the output to the compressor motor starter. Channel 2, the output to the oil pump starter. Channel 3 and channel 4 to slide valve load and unload solenoids. Then we're going to jump over to channel 11, which is our emergency stop MCR input. Next we have channel 12, the MSRB or motor starter readback. Then we have channels 13, 14, and 15, which are our interlocks for refrigeration high-level floats, the oil level floats, the sorry about this would be also a pump auxiliary running status or overview system permissives. These channels require a closed contact when safe and open to fail. And last, we have channel 16, our remote start. This can be any dry contact start signal from an overview system or any kind of switch that is going to remain closed while the compressor is supposed to be running. And here we have our part number for the main digital I/O board. That concludes the main digital I/O board. Next, we're going to take a look at expansion DIO card number 4. And here's the animation for the ribbon cable. This board has 2 digital outputs and 2 digital inputs. Again, the outputs are 120 volt AC dry contacts, and the inputs are 12 volt DC self-powered channels. Once again, this means no external power supply is required. And if you do supply an external power feed, this would damage these boards. Here we have the channel assignments for this card. And here we have the driver card for the digital expansion board number 4. This is required and for our expansion boards. This card is special for card 4, and I will show you where this mounts on the motherboard later on. And here we have the part numbers for both of these boards. Next, we're going to take a look at expansion DIO cards 1, 2, and 3. And here are the animation of the ribbon cable connection points to the motherboard. Each of these boards has 4 digital outputs. And again, these are 120 volt AC dry contacts. Here we have the channel assignments for all 3 cards. If assignment 2 is selected, assignment 1 may be found in a different location. And again with assignment 3. Again, here's the driver card for expansion boards 1, 2, and 3. And the part numbers for these boards. That wraps up the boards. The last part of the hardware that we're going to take a look at is the human-machine interface. The human machine interface, or HMI, touchscreen, is the user window or control panel to interact with the CPU. Let's take a look at how the HMI and the CPU are connected. Here's the animation of the serial cable connection to the CPU. If we rotate the HMI to the side and zoom in a bit, we can see the SD card access point. The SD card is used for job-specific storage of drawings, manuals, and videos. The SD card should always remain in the panel unless a technician is updating it, but they should be sure to return it to the panel prior to leaving the job site. Now, if we rotate to the bottom, you can see the connection on the HMI. First, we have the serial cable. Then we have our power supply, 24-volt DC power supply from our panel. If we have networking, we have Ethernet cable, which is used for VNC viewer, our Allen Bradley drivers, or Modbus TCP. Finally, we have our 2 USB ports for HMI program updates, screenshots, and report logging. Now let's take a closer look at the connections to the CPU. We have 6 wires in our purple serial cable that connect to the CPU Modbus port. They must be connected in the order shown here. This is with our purple serial cable supplied by Tennessee factory. If this cable is damaged, we strongly recommend replacing it with a cable from Tennessee, as it's already been pinned out. It is possible, if the cable is not available or in the proper time needed, if another cable is used, we would have to meter and pin it out. The last part of the HMI is the LED eye indicator that we get a lot of questions about. The eye has 2 colors and 3 indicator states. The first is green light on, meaning normal operation. The green light blinking is communication error to the HMI. And the third being the red light on, meaning an HMI hardware fault or a low HMI battery. The HMI battery is located in the back CPU section and will last years depending on panel usage. It is not accessible to be changed out as it will last quite a long time. It doesn't need to be changed, and if it does need to be changed, it would be a manufacturer. We would talk to the manufacturer about getting it replaced. That wraps up our HMI. Now that we know all the boards, let's take a look at a typical assembly that I mentioned at the beginning. We don't need the HMI or the CPU for this. And we'll start with the main digital I/O board. That is at the bottom or back layer of our assembly. Next, we will move the analog input into position. That's above our main digital I/O board. Next, we have the digital expansion boards 1, 2, and 3. These boards mount on risers in front of the main digital I/O board. Then we have the analog output board, which mounts on risers in front of the analog input board number 2. And the final board, expansion card number 4, since in our most common base model panel, expansion cards 1, 2, and 3 are not present, we'll move them out and we'll show you the most common mounting position for expansion card 4, which is mounted partially over top of the main digital I/O board and partially over top of analog board number 1. However, in most of our other combination panels, or our other model of panels, we have the expansion boards 1, 2, and 3. We'll clean this picture up a little bit here, and expansion board 4 gets mounted outside of the assembly within the enclosure, but above the wire chase there on the main board, or on the back plate. The last part that I'm going to highlight here is the expansion board driver cards. They're mounted on the motherboard as shown here. There's 2 connection points per board, and they're fastened or secured with a screw in the middle of the board. That's all for the hardware we're going to talk about today. Let's do a quick rundown of the model numbers, and then we'll wrap up with any questions. The full panel's model number always starts with MTP dash, and will always have a minimum of 3 numbers. The first digit indicates how many digital expansion boards the panel has. Options are 0, 1, 2, or 3. Expansion board 4 comes standard with our base model panel and all our models, so it's not included in this number. The second digit indicates how many analog input board sets the panel has. Options are 1 or 2. And the third digit indicates how many analog output boards the panel has. Options are technically 0 or 1. However, this is a standard board in all of our models. And here we have the boards that these numbers represent. Does anyone care to take a guess as to what this panel model number would be? And I'll give you a second here just to take a guess, just to do the calculations. If you are watching this in the recording, you may want to pause it so that you can have a little more time to guess. If you said 311, you are correct. We have 3 expansion digital boards, 1 set of analog input boards, and 1 analog output board. As I stated at the beginning, we have 5 standard model numbers. The MTP011 has an available 16 analog inputs, 4 analog outputs, 12 digital outputs, and 8 digital inputs. The MTP111 has an available 16 AI, 4 AO, 16 DO, and 8 DI. We have our MTP211, our 311, and our full spec 321. Here's a full breakdown of the model numbers with the available options of stainless steel window kit, purge kit, and the voltage options. The items in blue are not required in the model number. If nothing is present in the spots, it is just assumed that these options are not needed and the standard would be applied. This concludes the presentation part of our webinar. I'd like to thank everyone for attending. I hope it was a good information, whether it was new or a refresher for you. I hope I was able to provide a good understanding of our hardware in the MYPRO Touch Plus panel. We're planning to have our next webinar in 2 weeks on a breakdown of set points, capacity, other set points, and the VFD capacity pages within our panel. At this time, I'd like to open up for questions. You can either unmute yourself, raise your hand in the Ring Central meeting, or type your question in the chat window, whichever you feel most